Geometry students, welcome back. Welcome back. We are ready to work some practice problems related to quadratic functions. Let's get started. So, in letters A and B, what we need to do is give the coordinates of each parabola's vertex, then the minimum or maximum value, and the domain and range of the function. Ooh, that's a tall order. All right. So, the first thing we're going to do is the coordinates of the vertex. That's not too hard. We just look and see where the minimum or maximum point is. In this first one, letter A, the coordinates of the vertex appear to me to be -1, negative, let's see, 1, 2, 3, 4, -1, -4. Let's just see if we got that right, that first part. -1, -4. Now, is this going to have a minimum or a maximum? Well, notice that this is a downward opening parabola, and that means that it's going to reach a maximum point. The maximum point is going to be at -4, and that's what it says over here. Next, the domain and range of the function. Now, the domain is going to be which x values this function can possibly take on. And here's the thing, for every parabola, the domain is going to be the same. The domain is all real numbers because this parabola can go as far to the left as it wants and as far to the right as it wants. That's what these little diagonal arrows indicate. However, the range is going to be limited by the minimum or maximum. So the range of this parabola is from negative infinity. It can go all the way to negative infinity if it wants, is less than y, which is also less than the maximum. The maximum value is -4. All right, so let's just take a look at the rest of this answer. The domain is all real numbers, okay, because its x values could be anything. The range is all real numbers less than or equal to -4. Okay, it could go up to -4, the maximum, but that's the absolute maximum that it can be. Let's take a look at B. Same thing. First of all, the vertex is at 5, -3. This one's going to have a minimum at -3 because it opens upward. So it's going to come down to a minimum value. Okay, so we know that those are true. Now, let's see what the domain and range of this one are. Now, the domain is always all real numbers for a parabola. Okay, all real numbers. You can plug in anything you want for x. For y, though, you're never going to get a value that is less than -3. So we're going to say that the range is all real numbers greater than or equal to. So the y value that can come out of this is anything greater than or equal to -3. There we go. All right, let's move on to letter C. The zeros of each function. All right, so remember, a function can have 1 0, 2 zeros is probably the most common, or no zeros if it doesn't cross the y-axis. And wherever it crosses the y-axis, that's where there's a 0. Letter C, this one looks like it just barely kisses the x-axis, okay? So at the point, let's see, x equals 6, y is going to equal 0. That means that 6 is my only 0 for this function. X equals 6 would be a 0. I would write it out as x equals 6 as the 0 of this function, not just the number 6, but whatever. All right. This one, oh man, I'm going to have to look at how this scale works here. 2, 4. Okay, so -2, -4. That means -3 is one of my zeros. -6, -8, -9 is my other zero. -3 and -9 are the two zeros for this one. -3 and -9, right? Those are the two zeros for this function. And then this one has no zeros because it never crosses the x-axis. It never equals 0. In fact, the greatest this one's ever going to get is -2.5. It's never going to approach the zero, the axis. It can't be 0. It's always going to be less than -2.5. So this one has no zeros. All right. Letter F. Find the axis of symmetry for each graph. Okay. The axis of symmetry for this graph is going to be halfway between these 2 points. uh, because it has to pass through the vertex. The vertex is going to be halfway between these points. So you see, this point is 2, this point is 7. Halfway between 2 and 7 is, let's see, 4.5. So the axis of symmetry for this one is going to be x equal the line. It has to be a line. Line equals x equals 4.5. Let's just make sure I got that right. There we go. X equals 4.5. This one has an axis of symmetry. It's going to be halfway between these points. Okay, -8 and 3. To find halfway, by the way, all you do is -8 minus, let's see, -8 up to 3 is 11, right? There's a distance, if I counted it up, there's a distance of 11 between these two. And then halfway from 11 is, let's see, what's halfway to 11? 5.5. So I have to start at one side and go halfway. That means I need to go 5.5 units from here. Now notice this graph counts up by twos. So 1, 2, 3, 4, 5.5. That's going to put me at -2.5. -2.5 is halfway between -8 and 3. -2.5. So my equation should be x equals -2.5. Now, if that is giving you trouble, there's another way to find axis of symmetry as long as you have the equation. Do you remember we had the equation for this in the last lesson? So we're going to calculate this for h and I. This is going to be an actual calculation part of this lesson. So for letter h, we need to calculate the axis of symmetry. This is, so my letter A is 3, B is 12, and I ignore C, which is 4. Remember, this is ax squared plus bx plus c. All right, my equation for axis of symmetry is x equals negative b over 2a. That's going to be negative 12 over 2 times 3. 2 times 3. Okay, I'm going to put a dot here for times. There we go. So 2 times 3, let's see, negative 12 over 2 times 3. Well, that's just negative 12 over 6. Negative 12 over 6 is negative 2. So my equation, I'm just going to write it out cleanly. X equals negative 2. Let's see if that's my axis of symmetry. Boom. And then for my next one, for letter I, the axis of symmetry is going to be x equals negative b over 2a. Negative 6 over 2 times, and here we're going to be multiplying by, let's see, a is negative, my coefficient for my first one is -1. Remember, there's an implied 1 there. So it's going to be -6 over 2 times -1. That's -6 over 2. -6, oh, I'm sorry, -6 over -2. -6 over -2 is just positive 3. So my equation for my axis of symmetry here should be x equals 3. Let's see if we got that right. Bam, there it is. And this for this last one. This is kind of a toughie. We have to think about parabolas and what we know about parabolas to solve this. A chunk of lava flies out of a volcano from a height of 12,447 feet at a velocity of 608 feet per second. None of that matters. None of that matters because we have the equation at the end, okay? Find the highest point the lava reaches and how long it takes to reach it using the equation. Okay, so what we need to do is we need to think about axis of symmetry. Axis of symmetry. Because the highest point it reaches, the vertex, is going to be um, at the axis of symmetry. Remember, the axis of symmetry passes through the vertex. So here's what I'm going to do. I'm going to set up an equation for J for the axis of symmetry. It's going to be x equals, remember, it's negative b over 2a. So it's going to be negative 608 over 2 times negative 16. Okay? That's negative 608 over negative 32. Let me think about this for a second. Okay, I may actually have to use a calculator for this. 608 over 32 is 19. So my axis of symmetry is at x equals 19. And what does that mean? That means that the time, okay, so my x in this case is actually t. I should be using t because I have t time on my x-axis here, and y is height. Okay, so I'm just going to go ahead and make that adjustment because I'm using t instead of x, right? The time is going to be 19 seconds. It's in feet per second. It's going to take 19 seconds for that chunk of lava to reach its highest height. Then the question is, what is that highest point? Well, if I know t, I could figure out what the height y is by just plugging in t. So this is going to be, and I'm going to plug this into an equation. I'm going to plug this into a calculator. Negative 16 times 19 squared. Negative 16 times 19 squared plus, okay, I have to plug in 19 again, 608 times 19, 608 times 19. And then the last part is plus 12,447. 12,447. Okay, now I've got 18,223 feet. So y equals 18,223 feet. Let's see if I did this right. There's a good chance I made a mistake here because that was a lot of steps, but let's see if we did it right. 18,223 feet, 19 seconds. That's how you do it using axis of symmetry. Remember, the axis of symmetry is when you're going to reach your maximum or your minimum. If you have something happening that's going to be reaching a maximum highest point or minimum, all you need to do is find the axis of symmetry. That tells you what the x value on your graph, or in this case, the t value is going to be. And then you plug in that t value to find what the y value is at that point. By the way, one thing I can say about the graph of this, if I were to graph this out, the vertex is at the point 19, 18 to 23. That's the vertex because that's where the axis of symmetry crosses through the graph, right? All right, that's how you work these sorts of problems. You are ready to do numbers 1 through 30 for next time.